Okay, number 2, circle question. By the looks of it, part A1 is really straightforward. Pretty standard. Find the coordinates at the center and the coordinates of the radius of this circle. That might be able to aid us in a sketch as well. I tend to sort of, if you need to, put the x values next to each other and the y squared and the y next to each other to rearrange it first, and then take that plus 21 to become minus 21 on the other side from up there. Then it's completing the square job, because that will help us get it in the correct form. So that's going to be x plus 5 squared minus 25 plus y minus 4 squared minus 16 equals minus 21. At this stage, the minus 25 and the minus 16 can be grouped together to give you minus 41, and then you're going to take that over the other side. So it's x plus 5 squared plus y minus 4 squared. Remember, this was minus 41 over the other side, plus 41, and it's going to give us a positive 20, which means that the center is minus 5, 4. The length of the radius is the square root of 20, which can be simplified to 2 root 5. Part 2, bit of an unusual one by the looks of it, but it's good to have some problem solving questions in here. So the point P has coordinates minus 2, 0. Determine whether this point lies inside C, on C, or outside C. Now, I don't think there's necessarily needs a diagram, but I will do one anyway, because it might help us with the question in general, maybe later on. So far, what we have is the center is minus 5, 4. Let's say about there. There is that's A, which is the center of the circle. And we have another point, which is minus 2, 0 here, which they're calling P. And we try and decide whether that's inside or outside the circle or what. Now, if I work out the distance between A and P, and that is longer than the length of the radius, then that means that P is on the outside. If it's less than the length of the radius, then it means that it's inside. And if it's equal to the length of the radius, then it's outside. So I need to work out the length of AP. To work out the length between 2 points, we need those 2 coordinates, which we have. Stick them into this. A and P, so we have minus 2 and 0 for P, and we have minus 5 and 4 for the center, so that's going to be minus 5 take away minus 2 squared plus 4 take away 0 squared. 3, 4, I think that comes out to be 5. The mental arithmetic there. 9, 16. Yeah, that comes out to be 5. So, basically, is that more or less than 2 root 5? Now, not incredibly obvious by looking at 2 root 5, but if you type it into a calculator, 2 root 5 is 4.47. So 5 is obviously longer than that. So that means that the point P is longer than the length of the radius, which is, let's say, about like there. My circle now. Oh, goodness me. Pretend that as a circle, everyone. And that length means that it's P is on the outside. So we need to just clarify that. So P is outside C. Oh, I hate the diagram. Let's get rid of that. And draw a slightly better one. Maybe it's better if I do it quickly. Oh, yeah, there we go. That's all right. So, part B. The line L, the line, has an equation 2x plus 4. Let's just say that is like that, because the next bit says show that L is a tangent to the circle and find the coordinates of the point that they contact. Obviously, they contact there. Now, if 2 lines are equal to each other, then that means, if I put 2 lines equal to each other, the equations of the 2 lines equal to each other, remember the circle is a line, and I rearrange it, and I use my simultaneous equations method, then it'll give me the coordinates of intersection. If it's a tangent, there will only be one coordinate of intersection. So that is enough to prove that it is a tangent, because a tangent, it only has that one coordinate. That's my method I'm going to do. Okay, you could go down a similar route, I think, with the discriminant, I assume, with this, but I'm going to go for that one there. So we have our equations. We have the straight line equation there, and we also have, I'm going to go for this as my equation of the circle, the bit with the star next to it, rather than the original one, because it's a bit complicated. So I'm going to call this one equation 1. Oops. This one equation 1, and this one equation 2, and I'm going to sub 1 into 2. So I'm going to take 2x plus 4 and replace y in that equation with it. So it is x plus 5 squared plus, then instead of y, I'm now going to have 2x plus 4. But there's also a minus 4 next to it. Squared equals 20. Okay, expand this in brackets. First bracket, x squared plus 10x plus 25. Now the second bracket, that and that are going to cancel out, and I just have the 2x all squared, which is 4x squared. That equals 20. Now if I rearrange this, I'll collect things together. 5x squared plus 10x plus, what's that, is the 5 equals 0. If I divide through by 5, x squared plus 2x plus 1 equals 0. This will factorize. X plus 1, x plus 1 equals 0. There is just one repeated coordinate of x equals minus 1. So we need to say something like only one solution. So show, so L is a tangent. Okay, only one coordinate of intersection. Find the coordinates of the point of contact. Well, we've certainly found one of them. We found the coordinate minus 1. We now need just the y coordinate, and we can sub it into either one. So I'm going to sub x equals minus 1 into equation 1. So we have y equals 2 times minus 1 plus 4, which is 2. So the coordinate minus 1